So we want to graph this new graph. One of the things we've always done at the beginning is move any numbers that are on the left side to the right side. So I'll go +2, so that y is by itself. And this is one of those examples. Remember we made a special note yesterday for when we have horizontal translations along with horizontal stretches or compressions. Can you see that inside the square root we've got a +3 and we're multiplying the x by 3. So we have a horizontal compression and we have a horizontal translation. And whenever that's the case, before you can graph it or talk about your translations, you have to write it in factored form. So that means the number that's multiplied by the x, you'll factor that out, which will leave you with x plus 1 plus 2. So when we go to describe what we see here, okay, and I'll use abbreviations. This is a vertical reflection. This is a vertical stretch. Did I just add another number? Oh, I did just add another number. There's so many 3's that I just did that. So let's take that out. We have to go to fancy small eraser. There we go. So there's just a negative. And it should be, if I'm color coding things, blue. And so there's just a negative. So there is just a vertical reflection. I got a little bit 3 happy there. Just kept adding 3's. So now this 3 inside, this will be a horizontal compression. This 1 will make a horizontal translation. And this 2 will be a vertical translation. Underneath each of these things, we can write what we would do or what we would put above the arrows. So the vertical reflection, that affects your y values. You're going to multiply your y values by -1. Horizontal compression, you're going to multiply your x values by 1/3. This will go 1 to the left. And this will go 2 up. Now, there's our original graph. The one point for sure that you have to include is 0, 0. We must include 0, 0 because that's the starting of your square root graph. The other points that you choose on your square root graph can be anything. However, I do want you to think about what you're going to do. So look at the green here, all the things that we're going to do. And if you can choose a point that avoids fractions, you'll be happier as far as your graphing. It's not wrong if you choose a point and you end up with fractions. You can still plot those points and it will still be right. It's just sometimes a little bit nicer to always deal with whole numbers. So when I'm choosing my second point on my red graph, considering what's going to happen here, can someone tell me a point that you could choose that would avoid fractions in the end? 9, 3. Careful here. Do you see that 9 would be between here, would be halfway? Because you're going by 2's along the x-axis. So we have 9, 3. Why do we choose 9, 3? Well, we're going to multiply our x values by 1/3. So it would be nice if we chose an x value that divides nicely by 3. How come we didn't choose 3 then? There's not a nice y value with 3, right? The square root of 3 is like 1.73. It's not fun to plot, not fun to do your math with. So 9, 3 will be fine. And it will be enough just to use those 2 points. So we're going to look at 0, 0 and 9, 3. We're going to set up our arrows, stretches, compressions first, translations second, and see what happens. So above our first set of arrows, we put all of our reflections, stretches, and compressions. Basically everything that you're going to be multiplying by. So if we look at our brackets here, we know that we have to multiply the y values by a -1 and our x values by 1/3. For our translations, we have 2 translations. We know that we're going to be going 1 to the left and 2 up. So once we have those values, we can now apply it. If we multiply, we're still going to get 0, 0. Y by negative 1 will give us negative 3, and that 9 by 1/3 will give us positive 3. Now we're going to go 1 to the left and 2 up, 1 to the left and 2 up, and we've got our final 2 points. So when we go to graph those, negative 1 comma 2, again be careful here by the scale, negative 1 is halfway, but 2 is still 2 up. There's negative 1 comma 2, and 2 comma negative 1 would be right there. So we've got 2 comma negative 1 and 1 negative. Did I plot something wrong? Yes, I did. Negative 1 comma 2. So let's move that dot over to negative 1 comma 2. So notice, I mentioned this yesterday, but sometimes when you go to label your points, you can realize when you've made little mistakes. So I was trying to graph negative 1 comma 2, but I noticed that I had graphed 1 comma 2. So those checkpoints can be in there, and labeling your points can help you see that. Now when graphing this, we have to know which way it's going to go. And so the key thing that I showed you before is this 0, 0, this point right here, which I've circled in green, that's our starting point. That point became negative 1 comma 2. So this is our starting point here. So when I go to graph, I know that I'm going to start with my pen on that one and go through the other point. Another thing that I'll do as a check is I'll say, well, what kind of reflection did I have? I had a vertical reflection. Has this one been flipped over the x-axis? And does it have the right shape based on the shape that you had to begin with if you flipped it over the x-axis? Yes, so then you can feel like, okay, I feel like this is, I've done a couple checks in place. I'm pretty confident that this is the right answer. What is the domain and range of our blue graph? Well, the domain, the smallest value is negative 1, so we can write that our x values are bigger than or equal to negative 1. Our range, there is no smallest value because it goes down forever, but there is the biggest value at 2, so we can say that our y values are less than or equal to 2. You can do 8 and 10 for practice and work on number 9 from this morning.